Hello everyone, welcome to Festus NetLabs. In today's section, we want to configure eBGP, that is the External Border Gateway Protocol, not the iBGP. And we'll be using the free Cisco Modeling Lab environment to establish eBGP peering section between two Cisco iOS routers. We will configure our local LAN subnet to be advertised and reachable through BGP. And we'll be using two different methods to achieve this, the network command and the redistribute connected command. So come along with me, let's dive in. Okay, so let's log into the CML environment. I'll bring up the lab. So there is our lab setup. As you can see, I've already set up the topology. This is so that we can save time in this section. We have two routers, router 1 and router 2, each in their own autonomous system. Router 1 is in AX6501. Router 2 is in AX6502. And each router has a PC connected to it directly on the LAN side. Our goal in this lab is to get PC A to be able to reach PC B through BGP and vice versa. So let's start the lab by clicking on lab and start lab. Okay, we have router 1 and router 2 up now. We're waiting for PC A and PC B to fully boot up, or we can proceed with configuration. Let's start with router 1. I'll open a console access to router 1. We can do the configuration right from the CML console, GUI console, but I would like to use the secure CRT SSH client. So I'll bring that one up now. Okay, I already have the secure CRT connected to the Cisco CML console. I'll use the command list to list all the lab nodes, and to gain access to each lab I'll use the command open / the lab title / the node name / 0, which is the line that gives us access to PCA. I'll log in with Cisco. We've logged into PCA. I'll open another SSH to another node. Use the command list again. Open / lab title close / the node name / line. That's PCB. I'll rename the tab so we don't get confused for ease of identification. PCB. I'll do the same for this. PCA. Let's log into router 1 as well. I'll just change the name to router 1. Okay, let's open another tab for router 2. Router 2. That's it. Let's rename as well. Let's rename the title, the tab rather, PC router 2, and this rename to router 1. Okay, so we'll start with configuring the router 1 interface. Let's go to the global config mode, or the privilege mode, global config with config T, and let's see the interface first. Show IP interface brief. Okay, so let's go to the ETA 0/0 and configure the IP address. Interface ETA 0/0. Give it IP address 10.10.10.1 255.255.255.252. that's /30, and we'll bring the interface up with no short. Let's also assign a description. Let's call it 1 link to router 2. Assigning description is a good practice. It makes life easy for any other person who have the right privilege to the router or to the networks to be able to manage the device seamlessly. Okay, so the next thing is to go to the second interface that connects to PC A and assign the IP address as well. So we'll go to interface at 0/1 and assign the IP address 192.168.1.255.255.255.0/24. I'll bring it up with no short, give it a description as well. Let's say LAN link to PCA, and let's see what we have to show IP interface brief. Okay, so we have configured the interface address correctly. Let's do the same for router 2. I think we need to also assign name. Let's give it a name, host name router 1, and let's go to router 2 now and do the same thing. I'll go to the privilege mode and global config. Show IP interface brief. Let's assign the right IP for ETA 0/0, which is interface ETA 0/0. IP address 10.10.10.2.252/30. Bring it up with no short, and also description. One name to router 1. Let's also assign the IP to ETA 0/1, which is the interface pointing to PCB. Address 192.168.2.255.255.255.0/24. Bring it up with no short, and that's it. Let's see what we've configured. Okay, also configured router 2 interfaces correctly. So let's test and see if we have our point-to-point connectivity. See the ping router 1, which is 10.10.10.1. That's fine. We lost the ping due to app request. Okay, so let's also give you a name, host name router 2. Okay, so we need the point-to-point connectivity. We need to be able to reach router 1 and vice versa for BGP peering to come up. So let's also go to our PC and assign the right IP address. Okay, so this is PCA. Let's see, sudo IP address at 192.168.1.1/24 80. We'll also assign a default route, sudo IP address at default via 192.168.1.254. What's that? At default. Sorry, we missed the command sudo IP route, not address. Okay, that's it. IP address sure ETA 0. Okay, so we've configured the IP address correctly. Let's do a ping to test if we can reach our default gateway, which is ping 192.168.1.254. That's the router interface. That is fine. We can reach our router interface. Let's do the same thing for router for the PCB. I'll copy this and go to PCB and slam this. This is going to be 2.2, and I'll do the same thing for the default route for PCB. default route is 2.254. That's fine. Let's verify. Show IP address, show ET0. That's fine. We've assigned the IP address correctly. Let's do a ping to our default gateway, which is router 2 eta0/1 interface and 68.2.254. That's also fine. Now we're done with configuring the interfaces for all our nodes. The next thing is to set up the BGP peering between router 1 and router 2. Bring this closer. Okay, so let's start with router 1. We need to go straight to the router mode. We're already on the global config mode. Router BGP. We state the AS number 6501. We've initiated the BGP process with that command. Next is to state our neighbor, which is neighbor 10.10.10.2, which is router 2 1 interface, then remote AS. That's the AS of our neighbor, and that's 6502. Yes, with these two commands, the BGP peering will come up. So we need to do the same thing for router 2. Let's go to router 2. We are already on the global config. Go to the router mode by saying router BGP and the AS number 6502. Next is to put neighbor 10.10.10.1, which is router 1 interface, remote AS, the AS of router 1, which is 65001. The BGP peering should come up. Let's see. Yes, that confirms the BGP section is up, and we can also verify with the show IP BGP summary. Fine. So we have a neighbor with router 1, and it's just up for 15 seconds. We are not receiving any preface as expected because we do not have any BGP network advertised in our BGP. So we have our BGP up, but no network being advertised. You can also see do show IP BGP and see that nothing is displayed because we're not advertising anything yet. So the next thing for us is to advertise our LAN subnet using the first method, which is the network command statement. So on router 1, we'll use the command network. That's under the BGP process. Network, what's our LAN subnet 192.168.1.0. Then we'll call out the mask 255.255.255.0. We'll do the same thing on router 2. Under the BGP process, we'll have the command network and the subnet of router 2 LAN, which is 2.0, and that's it. If we run the command again, do show IP BGP sum, we should see preface received. That's it. We are receiving one preface from router 1. That's against what we were having before. We couldn't receive anything before, but now we receive one preface. If we check router 2 also, from router 1, we'll see the same thing. Do show IP BGP summary. We're receiving preface as well, and we can see the specific preface we are receiving with do show IP BGP. We can see we are receiving the 2.0 plus do show IP BGP. The LAN subnet of router 1 is coming to us. So we can test from PCA to PCB now with a ping to 192.168.2.2. That's PCB IP, and we can reach it now. That's perfect as expected. we can do a trace to see the path. Trace route 192.168.2.2. Our first up should be our default gateway, which is 254, yes, and the second up should be router 2.1 interface, yes, that's it, and the last subnet, this last up should be the device itself. So that's correct. Let's do the same thing from PCB. It's PCB. Let's do a ping to 192.168.1.1. that's PCA. Now ping is also successful. Let's do a trace to see. Trace route 192.168.1.1. First up should be the default gateway, that is 1.254. Yes, that's it. The next should be router 1 interface. Yes, that's it. And the next should be the device we're pinging itself. Good. So we have been able to reach, we have pings connectivity or pings working between PCA and PCB. We've achieved that using the network statement. Let's use the redistribute statement now. That's the second method. So I'll go to router 1 again and do let's see the BGP config to show section BGP. Okay, so I have this network statement that was slammed on earlier. I'm going to take that out, and by saying no network mask 255.255.255.0. I've taken that out. We'll do the same on router 2. Let's see, do show run section BGP. Oh, sorry, BGP. I'll negate that command. Okay, so we would stop receiving preface by now. Yeah, as confirmed. Okay, so let's change our configuration. Let's use the redistribute command this time around to advertise our LAN subnet, or to advertise all the connected network. Redistribute connected, and let's see the effect on router 1. CN show IP BGP summary. We're not receiving any preface yet. Let's see. Router 2 show IP BGP summary. Okay, on router 2 we're receiving 2 preface now. Let's see on router 1. Okay, the same thing on router 1 now, and let's see with the command show IP BGP neighbor 10.10.10.2 received routes. Okay, so it says inbound soft reconfiguration not enabled. It wants us to assign soft reconfiguration inbound on the BGP towards the PS. So let's see configure T. Let's go to the router mode, router BGP 6501. We'll say neighbor 10.10.10.1.2 soft reconfiguration inbound, and let's see the command again. Good. So if we use the command show IP BGP neighbor this and receive route, it shows us the routes that we are receiving from our neighbor, which is these 2 routes are coming from our neighbor. So it means our redistribute connected command is working. Let's do the same. Let's see for this as well. Show IP BGP summary. No, sorry. Neighbor 10.10.10.2 2.1 received route. Okay, we need to do the same. Config T router BGP 6502 neighbor 10.10.10.1 software configuration inbound show IP. So let's use the command again. Now we can see we are receiving these two routes. So the redistribute command will redistribute all connected interfaces and advertise it to the peer. You have to use that command in caution in a live production environment, because you would be redistributing every connected interface on that router. You may not want to redistribute or advertise all networks. In that case, you may need to use route map to filter what you want to advertise or receive from your peers. So let's verify if we can ping back to back now, having used the redistribute connected command. Let's see if we can ping PC2, and that's fine. Our pings are successful. Let's ping from PCB to PCA again. Our pings are successful as well. And if we say on router 1, if we do our show IP BGP, we'll see that we have the .2 coming to us from from router 2, and if we check on router 2 also show IP BGP summary or BGP, we see that the router 1 subnet, LAN subnet, is also coming from router 1 as well. We can also use the command, let's cancel this, we can also use the command advertise instead of received route. We can see what we are sending to our neighbors. Send advertise routes, and that shows us that we are sending these two routes to our neighbor, although this is a directly connected network towards the neighbor, but this is the main route we send it to our neighbor. .1, and from router 2 also, if we say advertised, we see that we're advertising this subnet to our neighbor as well. So there you have it. We have successfully configured eBGP between two Cisco iOS routers. We advertised our local LAN subnet using both the precise and the broad redistribute connected method. We also verified that everything works with end-to-end pings from our PC. If this video helped you, kindly hit the like button and subscribe for more practical lab like this. Let me know your thoughts about this video, and if you have a preferred topic you would like to see next, kindly put it in the comments as well. Thanks for watching, and I'll see you in the next one.